Okay, in this video we're gonna build the same hyperbola that we did in the last video. The difference being our foci are referenced on the XY axis or the XY plane in a different place. Instead of at minus 10, 0 and 10, 0 like they were before, I've got A at minus 3, 4 and B at 17, 4. And this is part of the discussion we've had all along with analytic geometry. When we were doing proofs, you remember we would draw our picture and then we would place the axis on there and to make it as beneficial as possible to help with the algebra. Okay, so here we're encountering a situation where we need to build a hyperbola and we need to reference it on the XY plane. But that doesn't mean we have to initially build it there. So we're kind of going to do that same thing we did when we were doing proofs. I'm gonna build I'm gonna place the axis on here like so. So I'll call this X prime, if you will. And of course then I want to make things nice, just like in before we had, the two foci were minus 10 and 10. So the origin was right in the middle. Well, it can be here. You take 17 and you take minus 3, add them up, find the average, and you've got 7. So our origin on my X prime, Y prime plane. So origin here, but 0.74 in reference to the XY plane. So here, this would be then where my Y axis would be, or my Y prime axis. And so now, basically I have the same situation as I had before, because on X prime, Y prime, again, we have the origin here. This point, foci A, would simply be at minus 10, 0 on the X prime, Y prime plane, and this would be 10, 0. And so by making that little shift, by placing that plane on there, not the one I need to reference, but the one I want to when I'm going to build my hyperbola, then things become very nice again. Again, perhaps we've got this point P that's up here again, okay, and we know that the distance here is 13, just like we had the last one. The distance here is 20. Look like my scale's a little off this time, excuse me, but it's the same thing. So then, watch what I hit on a touch screen. So then in the X prime, Y prime plane, if we reference that, if that's our reference, then just like in the other video, I'll just write it down, we get the hyperbola for X prime squared over 49 minus 4y prime squared over 351 equal to 1. That's in reference, so that's the hyperbola I get in reference to X prime, Y prime plane. But as we talked about in like our first video in this section with translation, then we can simply adjust this. We can make a translation, okay, to reference then the same hyperbola. Nothing is changing about a hyperbola, not the location, not anything. But now we're going to reference the XY plane, and we would replace X prime. I'll just write those down. We'll replace X prime with X minus 7, and we'll replace Y prime with Y minus 4, because our origin on the XY is down here, and so That's our shift, our translation. And so then we get the hyperbola, the same hyperbola, but an equation that references the xy plane. We get this. Okay. And so if we go to GeoGebra, you see, oops, see that I've typed it in up here at the upper left hand corner, 4 times quantity x minus 7 squared over 49 minus 4 times the quantity y minus 4 squared over 351. You can't see the equal 1, but it's there. And so yeah, we get our hyperbola. Same thing goes, this distance is still, the difference here is still 7 all the way. So it's the same hyperbola. It's just that we went from referencing, we built it in reference to, just to go back here real quick, we built it in reference to the x prime y prime plane, and then we did a translation so that we had the same hyperbola but now referenced in the plane where we needed to reference an xy plane. Okay.